Using the law of sines, there's something called the ambiguous case. And in this video, we're going to be taking a look at the ambiguous case where we actually get two triangles as a solution. So for our example, angle A is 43.1 degrees, side A is 186.2, and side B is 248.6. So we're going to find the missing angles and side for both possible triangles. So the first thing is I see the information I have, angle A, and side B, and from this I can use the law of sines to find angle B. So using the law of sines, sine of 43.1 divided by 186.2 equals sine B over 248.6. Now from here I can solve for sine B by multiplying the 248.6 over. So I'm going to get 248.6 sine of 43.1 divided by 186.2. And that's going to equal sine B. Now to get B itself, because I need the B but without the sine, I'm going to take the arc sine of both sides to get rid of sine here. So when I do that, I'm going to have arc sine of 248.6 sine 43.1 all over 186.2, which will give me B. And when I plug this into the calculator, and make sure that your calculator is in degree mode and not radian, we're going to get B to be 65.8 degrees. So for triangle number 1, we have angle B being 65.8 degrees. Now we still need to find angle C and side C. So angle C is fairly easy to find because we already know what B is and we know what A is. So angle C is just 180 minus 43.1 minus 65.8. And when we do that, we're going to end up with 71.1 degrees. So that is my missing angle here, 71.1 degrees. And now I still have to find side C. And I can just use the law of sines again to figure that out. So separate that, and this over here. So side C is going to be sine, and I'm going to use A again. So 43.1 over 186.2 is going to equal sine of 71.1 over C. Now I'm going to solve for C. I'm going to multiply the C over, multiply the 186.2 over, and divide the sine 43.1 over. So I'm going to end up with C equaling 186.2 sine of 71.1 all over sine of 43.1. So again, plugging this into the calculator, making sure it's in the right mode, I'm going to get C equaling 257.8. And that's my missing side C. So 257.8. So this is the missing angle and sides for my first triangle. And that's all well and good, but how do we know that we have a second triangle? Well, we know this by using the fact that we're relying on A being less than B. A is less than B, so we're going to show that sine B is less than 1. So sine B, and we know that B is 65.8 degrees, so sine of 65.8 is equal to approximately 0.91, which is obviously less than 1. So using that fact that sine B is less than 1 right here, we know that there are two triangles. So since we have triangle 1, let's find triangle 2. So let's use the fact that B is 65.8 for angle B. To find the next angle B for triangle 2, we're going to do 180 and subtract our previous angle B, 65.8. And that's going to give us 114.2 degrees. So angle B, 114.2 degrees. Angle C is very easy to find, just like we did before. We're just going to do 180 minus what A is, which we know is 43.1, and then subtract angle B from this one, 114.2. And when we do that, we're going to end up with angle C being 22.7 degrees. So angle C, 22.7 degrees. Now we have to find side C. And we can do that by just using law of sines. And I'm going to use A again to find C. So sine of 43.1 over 186.2 is equal to sine of 22.7 over C. Now I'm going to solve for C. I'm going to multiply the C over, divide the sine 43.1 over, and multiply the 186.2 over. So I'm going to get C equals 186.2 sine of 22.7 divided by sine 43.1. And so when I do this here in my calculator, again, make sure it's in degree mode, I'm going to get side C to equal to 1 decimal place, 105.2. So my last side is 105.2 for side C. And this would be triangle number 2. So these would be the missing angles and side for the second triangle. And here are my two triangles and the work to find both of them.